Good day to you. This is teacher LELAND, Alejandro, and we're going to do today linear models, and these are worded problems using linear equations. We shall see the problem sets after a little while. So let's check on the worded problems on the other side. Linear models, we shall start with the first number. Okay, so linear models, and the instruction is write an equation in slope-intercept form to model each situation. We already know slope-intercept form in our practice exercises in line equations. And the format of this is y equals mx plus b. And we already know those. M is slope and b is the y-intercept. For the first number, we shall get the data here. And if you read the first problem, you see you rent a bicycle for $20 plus $2 per hour. Now the $20 payment will be at the initial time. That will be at time 0. So this must be the given y-intercept, and that goes to our b. That should be the $20. And then for the $2 per hour, that means 2 over 1, $2 for every 1 hour. This is the slope m. So we're going to set m $2 for every hour. So our input variables, or two variables that we're going to use, is the r for the rent, and then we'll use the t for the time. So we shall be able to write the required equation. All right, so let's go up to our whiteboard. Let's have the solution over the whiteboard. Okay, so we shall clear this one first. We shall start with the first number. Okay, number 1. We shall let r, that will be our rent, and this will be in dollars. That should be in dollars. And then we shall use the small t. This must be the time, and this will be in hours, like that. And then our given data, we have our slope. This is actually $2 per hour, and our y-intercept b, this is given at $20. If you notice that in the other screen there. So our b is 20, our m is 2. And we shall use the slope-intercept form. Now in our practice line equation, that is y equals mx plus b. There. Now notice the y, that is the dependent variable, and that will be our rent. So we shall replace this with capital R, the rent, and our x, the input variable is time. And this will be the small t there. And then we can now use our given data to come up with the equation. This is r equals to m. Our m is the 2, and then times t plus the 20. Yeah. So this is our required equation for this particular problem. Now let's have another one, the second. Let's have the second. Should be able to clear this and then get the second. All right, for the second problem, we have to go back to our problem set. Here is our number 2. Okay, we have the second number. An auto repair shop charges $50 plus $25 per hour. Okay, as initial payment, that's the $50, and that will be for our small b, and that will be for the initial payment. Now for every hour in the auto repair shop, that will be $25 so for every hour. So this will be your slope. That is 25:1. Okay, that you'll be able to get the slope by the way you see the units. You have amount per unit time. So that's the slope. Amount per unit time. So that should be the 25 here. There. And so the variables that we're going to use here, we can say use C for the cost or charges, and that'll be in dollars. And then again, that'll be the second variable, that will be time, and that'll be in hours there. So if we make use of this data, go back to our screen for our solution, we shall be able to do this on the whiteboard. And here's our second number 2. We let the variables C for the cost, and this will be in dollars. And we let the small t, this will be time, and this will be hours there. And our given will have to be the B, that's the initial payment, that'll be our $50. That's a small b in our slope-intercept form, and this must be the $50. And our slope, that will be about $20 for every hour. So how do you check which one is B and which one is M? If you see 2 units, that will be the slope. And in this case, it's the $25. And we start again with our slope-intercept form equation. That's y is equal to mx plus b. That will be our slope-intercept form. And let me just put what I have deleted there. Let C, that will be equal to cost, and this will be in dollars there. All right, this will now be y is equal to mx plus b, and we're going to change the y, which is something that we'll be using the C, and then x will be our t there. And then we do direct substitution to this, and we shall come up with a required equation. Our slope is 25 times the time plus the slope-intercept, which is $50 there. So if you're going to interpret this equation, at time 0, that would be 25 times 0. And you will have something like 0 plus 50. And the cost is $50. Now, after 1 hour, that becomes 75, because that will be 25 times 1, that will be 25 plus the 50. That will be $75. And then another hour, that will be another 25. And that becomes $100 there. So at time 0, you get $50. So that will be the B, which is the y-intercept in ordinary linear equation. So this will be the answer for number 2. That's the required equation in slope-intercept form. Let's have another number. All right, let's proceed to the third, the problem set. All right, let's have the third number here. Okay, here's the third number. A candle is 6 inches tall and burns at the rate of 1/2 inch per hour. Okay, this time it's not something like the cost which increases. This time we have a height of the candle which is decreasing. So our 1/2 inch per hour must be a negative. It must be a negative. So this will be a negative slope. And so what we have for number 3, we will be using h for the height. And this is actually in inches. And we will be using t again for time. And this will now be still in hours. And then we have the given. Okay, the 6 inches is the initial height of the candle. That will be at time 0. At time 0, it's 6 inches. So that should be our y-intercept. So this will be the given. And this will be B, that's 6 inches. And our M, the slope, it's a negative because the output is decreasing. So this is negative 1/2 inch for every 1 hour there. And so we shall be able to write the required equation in slope-intercept form. So let's continue and go back to our working screen and start the third number. Okay, here's the third number. We start with 3, and then we have the representation of the variables. Let h, that should be our height, and this will be in inches. And the input variable is t, and this will be for a time, and this will now be in, this will still be in hours there. Okay, so for the given, we're now going to have the initial height at time 0, that will be our 6 inches there. And then our slope m is a negative, because this time our output is going down, decreasing. So in a drawing, that will be sloping downward to the right. And so this will be a negative 1/2 there, negative 1/2. And so we're going to start again with our slope-intercept form equation. This will be mx plus b. Y is equal to mx plus b. And then we're going to change the variables. Okay, our y will have to be using the height. And then our x will have to be the time there. And then after which we'll be doing the direct substitution. This will remain h, the variable. Our m is negative 1/2 there. And this will be multiplied by time. So take note, this means negative 1/2. It's supposed to be like this. Like that. Negative 1/2 times time. And this will be added to 6 inches. So at initial time 0, your height is 6 inches. And then it goes down for every hour by 1/2 inch. This is the working equation, and this will be for the third number. Okay, so we shall do the fourth. Let's do the fourth number, and let's see the problem set again. Let's see the fourth. Okay, here's number 4. It's something to do about temperature. Something about temperature. So number 4, the temperature is 15 degrees and is expected to fall 2 degrees each hour during the night. Okay, so this time it's temperature, and in the starting time, it's 15 degrees. And then as we move to the night time, you can see the word fall, and that means it's going down. And we're going to have a negative slope here. So we shall get the correct variables first. For number 4, our variable will be, let's say, capital T for temperature. And then this is versus time, so hours. So we will still be using a small t for time. And then for our given data, at initial time 0, it's 15 degrees. So we will be using the small b, the y-intercept, using the 15. And then our slope, what is our slope? Is it positive or negative? Okay, it's getting colder. So the number is going down. So this 2 degrees will be used as negative. Okay, so this is our m. It's negative 2 degrees for every hour there. So that's it for the given in number 4, and we shall continue with the working equation. All right, let's go back to our screen, whiteboard. Okay, here is number 4. Let's erase number 3 first. Okay, here's number 4. We start with the given data and variables that we're going to use here. We'll be doing the letter T, capital letter T. This will be for the temperature. And this will be in degrees, okay. All right. And we shall extend this so that the word is up there. All right. And we shall continue with the other variable. The input variable is small t, which represents time, and this will still be in hours there. Okay, so let's go back to our required equation. Slope-intercept form is y is equal to mx plus b, and we shall now change the variables at this point. But before that, let's have our given. Our given, which is the y-intercept, the initial temperature is given at 15 degrees. Okay, this is given at 15 degrees. Let me adjust that. 15 degrees. And the slope, the temperature is going down, going to the evening. So this is by about 2 degrees. That will be negative. And this will be 2 degrees per hour there. And so we shall now replace our variable y with capital T, and we will have mt, m and letter t plus the small b there. Okay, we shall now use the m and the b in that equation and come up with a required answer. So this is temperature equals negative 2 degrees times time plus the 15 degrees there. So if you analyze this particular answer at time 0, the starting time, it's 0 times negative 2, which is 0, plus 15 degrees. Your temperature at the starting time is 15 degrees there. And then as time goes by to the evening, that slowly goes down. That will be a reduction of 2 degrees for every hour. So it will be 15, and then 13, and then 11, 9, and so forth and so on. So it's going down. All right, so that will be the required answer for number 4. So let's have one more example for the slope-intercept form, going back to our worded problems. All right, let's have the number 5 over here. Let's have the number 5. A computer technician charges $75 for a consultation plus $35 per hour. Okay, if we analyze this problem, the cost at time 0, okay, upon going into the shop, all right, you pay $75. That's for the consultation. Then after an hour, you have to pay $35 when the computer technician is going to fix your machine, like that, and so forth and so on. Another 35 for another hour. It's like that. So we shall use the data given there for number 5. Our variable here again, let C for the charges or cost, and this be in dollars. And then this is versus time again. So T is time, and this will be per hour there. And our given at initial time 0, consultation time, that's $75. That must be the y-intercept at time 0. So that will be $75. And then your slope m is it increasing or decreasing? As time goes by, you add more amount there as you stay there in the shop waiting for your, say, computer. So that means the cost is increasing as time goes by. All right, so this will now be, say, 35 positive. This will be 35 for every 1 hour, like that. And so we shall have the required equation in the whiteboard. So we shall check our answer over here. Let's remove number 4 first. Okay, then we start our number 5. Okay, number 5, we let the variable C for the cost. And this will be in dollars. And then this is still versus time. This will be time, and this is it minutes or hours? That will still be hours. Okay. There. Okay. Still our given. Let's have our given. Okay. What do we have there? Our given is $75 for the y-intercept. So this will be like 75 there. And then M Our slope is for every hour we add $35. So that means that is 35 to 1. Okay. Remember, there are 2 units in the slope. So this is amount per unit time. So this is 35 over 1 hour. So that's the slope. And this is positive because your cost is going to increase. Okay. So we start with the format for slope intercept. Again, ymx plus b. And then we now change variable c. That's for the cost. And our m will remain m. Our x, the input, is t, time. So the cost depends on the time. Okay, the cost depends on the time. So the cost is your dependent variable. The t is the independent variable. So this is our new working equation. We will just be using a direct substitution method. This is 35 for the slope times time plus our initial $75. And there's number 5. And this will be our last problem for this session. I hope you learn from these examples. We're going to continue with other examples next meeting. Okay, thanks for learning. Bye-bye.